In this lesson, we'll be talking about temperature and thermal equilibrium. Our main objectives are relations of temperature to kinetic energy of both atoms and molecules, changes in temperature when two objects reach equilibrium, and the last one for the use of temperature scales and the conversion from one scale to another. So what is temperature? Temperature is a measure of the average kinetic energy of the particles in any object or any substance. If temperature decreases, these particles also decreases, causing any object or substance to turn cold. But if temperature increases, these particles also increases, causing any objects or substance to turn hot. There are three forms of energy: translational, rotational, and vibrational. An example of translational energy would be a train moving on the track, and for rotational would be the rotatory motion of a helicopter blade, and for vibrational would be the act of plucking a guitar string. Now we're going to talk about thermal equilibrium. Thermal equilibrium is when all parts of the system are at the same temperature. An example of this is putting a warm can of soda in a bucket filled with cold water. In a couple of minutes, the soda and the water will transfer and exchange temperature until both the soda and the water are at the same temperature. Did you know that matter expands when temperature increases? This is called thermal expansion. The reason for this is because the heated molecules move way faster and take up more space, causing it to expand. Now we are going to talk about how we can measure temperature. It is widely known that temperature is measured with the help of a thermometer. But do you know how it works? Well, it's simple. Most thermometers use a glass tube with a thin column of mercury. And once the temperature increases, the volume of the liquid expands, but if temperature decreases, the liquid will scale down. And the change in length of the liquid column is proportional to the temperature change. Temperature units depend on the scale used. So if you want to convert Celsius to Fahrenheit, all you have to do is calculate 9/5 times Celsius temperature plus 32. The values of both Celsius and Fahrenheit can be negative or positive, but since the kinetic energy of the atoms in a substance must be positive, the absolute temperature that is proportional to that energy should be positive also. And to convert Celsius to Kelvin, we take the Celsius temperature and add 273.15. Kelvin has an ice point of 273.15 Kelvin and has a steam point of 373.15 Kelvin has an ice point of 273.15 Kelvin and has a steam point of 373.15 Kelvin. It is used for physical chemistry, gas laws, astrophysics, thermodynamics, and low temperature physics. Celsius has an ice point of 0 degrees Celsius. It also has a steam point of 100 degrees Celsius. It is used for meteorology, medicine, and non-scientific uses. It is also used for other sciences internationally. Fahrenheit has an ice point of 32 degrees Fahrenheit. It has a steam point of 212 degrees Fahrenheit. It is also used for meteorology, medicine, and non-scientific uses. It is mainly used in the United States. That's all for today, and thank you for watching.